One of the best parts about X-ray diffraction is that two crystalline phases are present in the sample, though both diffract independent of each other. This means that the pattern for a pure crystalline compound will readily reveal the nature of impurities. If the diffractogram for a pure phase is known, then it can essentially be subtracted to isolate the peak location of impurity peaks, which helps in their identification. This also means that we can purposefully add additional material to provide an internal reference point based upon their own known diffraction peaks. The impurities mentioned can range from a variety of different sources and can be monitored as long as the quantity of the crystalline impurity is sufficient enough for observation. In the context of pharmaceutical development, this can be critical in process chemistry, salt disproportionation, and changes in hydration. For chiral compound, diastereomers typically have unique diffraction patterns, and the relative impurity profile can be inferenced from the diffractogram. Crystalline salts may begin to disproportionate to the free base or free acid when stored at elevated relative humidity. And if we have reference patterns of each available, we are able to monitor the kinetics of this conversion. Now, if a sample is either too thin or too thick, then the peak will end up with an offset based upon their position. Microcrystalline silicon is available as a standard reference material, or SRM, which can be used to anchor a diffractogram. The 111 millindex silicon standard has strong diffraction peak at 28.48 degrees. Excellent for adjusting any needed horizontal offset for peak positioning. Several SRMs exist for peak intensity, but those will be discussed in the next video.